Hello everyone. In this video, we have a quadrilateral whose four sides are given. We have to find the area of this quadrilateral. And you might know that we don't have a direct formula to find the area of a quadrilateral. However, we know the formula to find the area of a triangle. So how can we use triangles in this case? So before I proceed, I would advise you to give this problem a try, and later on you can come back and watch this solution. I would like to bring in triangles into the picture. For that, I will join the points A and C. If I join A and C, AC will be a diagonal of this quadrilateral. So this diagonal AC divides the quadrilateral into two triangles. So all I have to do is find the area of both the triangles and just add the areas to get the area of the quadrilateral. Okay. First of all, I would like to find out the length of this diagonal AC. Okay, this AC is very much required for us. So how can we find AC? Yes, so we can use the Pythagoras theorem, isn't it? So we have a right angle triangle here. This angle B is a 90-degree angle. So we can use Pythagoras theorem. What is Pythagoras theorem? I'll just recall it here. So if you have a right angle triangle, and if I name the sides as A, B, and the longest side is C, which we call as hypotenuse, then according to Pythagoras theorem, square of the longest side, square of the hypotenuse, that is C square, will be equal to sum of the squares of the other two sides, that is A square plus B square. So in triangle ABC, we can apply Pythagoras theorem. So in triangle ABC, longest side is AC, right? AC is the hypotenuse. AC square will be equal to AB square plus BC square. So here AB square, so I will write AC square as it is. AB is nothing but 24, so 24 square plus BC is 7, so 7 square. Now 24 square is 576, which is 24 into 24, plus 7 into 7 is 49. So we have AC square is equal to 576 plus 49, which is 625. Now take the square root on both sides. AC will be equal to square root of 625, which is nothing but 25. So this unknown side here, right, which is AC, it is 25. Okay, so this side is 25. Now we have two triangles, right? To find the area of the quadrilateral, we have to find the area of both the triangles and add them up. Finding the area of this right angle triangle ABC is very easy, because if we have a right angle triangle, okay, then we have two perpendicular sides, right? So if one side acts like the base, then the other perpendicular side will act like a height. So because of this, we can use the formula half into base into height to find the area of the right angle triangle very easily. So let's do that. Okay, so first of all, let us find the area of the triangle, area of triangle ABC. So area of triangle ABC is nothing but half into base into height. So base is 7 and height is 24, right, for the right angle triangle. Now you can solve this one. So we can do 2 ones are 2 and 2, 12 times 24. So 7 times 12 will be 84. 84 units, okay, 84 square units. Okay, I'll write square units here. This is the area of the triangle ABC. Now let's go to the triangle ACD. You can observe that triangle ACD is not a right angle triangle. Okay, so how can we find the area of triangle ACD? So we know that ACD is not a right angle triangle, but we do know that ACD's all three sides are known, isn't it? So when we know three sides of a triangle, we have a special formula to find the area of a triangle, and that formula is nothing but Heron's formula. So we have to use Heron's formula in this case. So what does Heron's formula say? I will write it here. So we have to use Heron's formula to find the area of triangle ACD. Okay, so area of triangle ACD, according to Heron's formula, it will be equal to the square root of S into S minus A into S minus B into S minus C. Now what is S here? S is nothing but the semi-perimeter. So we have to find the value of S first. Okay, so let's find the value of S here. So S is the semi-perimeter. So S is nothing but the sum of all the sides, A plus B plus C, which is the perimeter, divided by 2. So that's why we call it semi-perimeter. Now ABC are nothing but the sides of the triangle. So A is 25 plus B is 27 plus C is 26 divided by 2. Now if you add all these values up, you get 78. 78 by 2 will give us 39. 39 is the value of S. Now we know ABC, we know S. So let us find out the value of the area of triangle ACD. So area of triangle ACD will be equal to the square root of, what is S? S is 39. 39 into, so we do need the picture over here, right? So I'll bring the picture. Okay, 39 times S minus A will be 39 minus the first side, let's take it as 25. Okay, into 39 minus the second side, which is 27, into 39 minus the third side, which is 26. Okay, so now we have to solve this term inside the square root. So let's try to find out the square root of this term. So first of all, 39 is as it is. 39 minus 25 will be 14, and 39 minus 27 will be 12, and 39 minus 26 will be 13. Okay, how do we find the square root of this big number over here? So we will use prime factorization for this case. So let us express all the numbers in terms of their product of prime numbers. That is 39 can be expressed as 3 times 13. Okay, let me use a different color here. So 3 times 13 is 39. 14 can be written as 2 times 7, and 12 can be written as 3 times 4 into 13. 4 is not a prime number, but still we don't have to express 4 as a prime number product. We can directly find the square root of 4, right? Yes. So now you can observe here under the square root. Okay, let me not write the square root here. So inside the square root we have 3 in pair of 2, right? So we have 3 2 times, so we can take one of the 3's outside. In the same way, you can see that we have 13 also in a pair of 2, right? So we can take 13 as well outside. Okay, because square root of 13 into 13 will be 13. And we know that square root of 4 is nothing but 2, right? Square root of 4 is 2, and we have 2 into 7, which cannot be expressed as prime numbers further, so we'll just write them as it is. 2 into 7, which is 14. Okay, so here we have 3 into 13, which is 39, into 2, which is 78. 78 square root of 14. You can keep this as it is, or you can find the square root of 14. Okay, I will tell you a little trick here, shortcut trick that you can use to find the square root of 14. So we want to find the value of square root of 14, right? First of all, we have to find out the nearest perfect square of 14. Who is the nearest perfect square of 14? It's 16, right? Because we know that square root of 16 is 4. We know that square root of 9 also is near to 14, but you can see the difference here, right? Between 9 and 14 the difference is 5, between 14 and 16 the difference is just 2. So we'll take the nearest one, that is square root of 16. Since square root of 16 is 4, square root of 14 has to be less than 4, right? So it should be 4 minus something. Okay, 4 minus something. What is that something? So be careful over here in this step. So 4 minus, you have to take the difference. Okay, take this difference 2 divided by, write 2 here, 2 times this number, that is 4. Okay, write that number 4. Now you have to simplify. If you do this, you'll get the approximate, very nearest value of the square root of 14. So let's try to simplify this. So 2 and 2 can be cancelled out. So we have 4 minus 1 by 4, which is 4 minus 0.25, which is equal to 3.75. So this is very near to the value of square root of 14. If you take a calculator and check, the value of square root of 14 is 3.74. Okay, so it's very near, isn't it? So we have the area of triangle ACD as 78 times square root of 14, which is 3.74. And if you solve this, you get the value as 292.5 square units. This is the area of the triangle ACD. Okay, so we have found out the area of triangle, both the triangles here. That is, area of triangle ABC was 84 and triangle ACD area is 292.5. So to find the area of the quadrilateral, we just have to add the areas, add both the areas. Okay, if you want, I'll get the diagram once again here. So we have the diagram over here for your reference. Okay, so as you can see here, area of quadrilateral ABCD is nothing but the sum of area of triangle ABC plus the triangle ACD, right? Both the areas have to be added. Area of triangle ABC, as we have calculated above, is nothing but 84 square units, right? So it is 84 plus the area of triangle ACD, as we have calculated, is 292.5. And if you add both the values, you get the value as 376.5 square units. This is the area of the quadrilateral. Okay, it's a very simple problem, a high school level problem, but still it's a very popular problem, especially in exams like Math Olympiad. This kind of questions do appear often. So I hope all of you enjoyed the solution. If you like my content, do support me by liking this video and do subscribe to my channel. I will see you in the next video.